Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Then we would start right away after waiting for 1 or 2 minutes. Anonymous fan. Hello, sir. Hey, Anonymous. Hey. Okay. Okay, good to go. Let me. Yeah, I'm absolutely visible. Okay. So we would wait for just 1 or 2 minutes, then we would start right away. Okay. Okay. Just let me know if I'm visible as well as equally audible or not. Okay, so we would wait for just 1 minute. Okay, when it is 3-1 or 3-2, we would start right away. The people who are watching, can I have a quick +1 from them? Am I visible? Okay, I'm perfectly audible. Okay, good afternoon everyone, by the way. Good afternoon everyone. Okay, so we would start right away. So today we would be doing yesterday's problem of the day, that is count total set bits. Okay, this is a bitwise problem. Okay, and the success percentage of this problem is 45%, and the difficulty level of this problem is medium. Okay, good to go. So let's move forward with the problem statement explanation. So you are given a number n and you need to find the total count of set bits for all the numbers from 1 to n. Okay, so suppose the number is 4. Okay, so we have from 1 to n, we have 1 as 0, then 1 0. Okay, and then 1 1. Okay, and then 2 3, and then 4 would be 1 0 0. Okay, so now how many set bits are there? We have 1 set bit, 2 set bit, 3 set bit, 4 set bit, and 5 set bit. This is how the answer is 5 here. Okay, good to go. Can I have a quick +1 from everyone, because the chat looks absolutely empty and it seems like I am teaching myself, but I can see the live viewer count as 7, and this is a very interesting problem, I can assure you that. So can I have a quick +1 if possible? Okay, so now to solve this problem, one way to solve this problem is that we would take the numbers from 1 to n itself. Okay, and we would count the set bits in each of the number. How we would count the set bits of each of the number? Suppose we have a number as 101. Okay, so we can count the set bits of this number by doing what? While this is greater than 0. Okay, we would do 101 and with 1. Okay, if the answer is 1, we would increase one count. Okay, the count would be increased, and then what we would do is we would do right shift of that number. So right shift would make this number like this, and then again we would do a and with 1, and then 101 is equals to 0. So we won't count it because that is not 1. Again we would do right shift till the number is greater than 1. Again we would do and with 1, and this is 1 itself, and we would increase the count. 1 plus 1, that is 2 here. Okay, this is how we would proceed. Okay, good to go. So I don't see a single message today. Am I in the error, or I don't know if no one is replying? Okay, let me see for myself. Okay, no one is replying. Okay, okay, I'm extremely sorry, but if possible, do reply me. Okay, do reply, because it seems like I'm teaching myself only. Okay, so good to go. So now this would take a order of big O of n. Why? Because we are iterating each of the numbers, and for each of the numbers we are doing the log n. So n log 2n itself. Okay, so we would do this and that would be good to go. So this is how we can proceed. And what is the next thing? Now to next thing, to do the bit manipulation, whenever we come across a problem which is a bit problem, the first thing that we should do is we should convert all the decimal representation to the binary representation. Okay, this is the first thing that you should do. Suppose we are given the number of 1 to 11. So we need to tell the number of set bits from 1 to 11. So 1 is like this, and 2 is like this, 3 is like this. Okay, just a sec. Okay. Can anyone just reply in the chat? It seems that there is no one there in the chat. Okay, so 4 would be like this, 5 would be like this. Okay, good to go. And then 6 would be like this. Okay, 7 would be like this. Okay, and then 8 would be like this. Good to go. 9 would be like this. Okay, 10 would be like this only, and 11 would be like this. Okay, just check if this is ordering is clear or not. Okay, just check if this ordering is clear. I hope it should be clear. I don't think, but it might be the case that I might missed one. Might missed. Let me check it again. Yeah. Okay, good to go. Then we are appending one itself. Then we are moving one. Okay, I think I'm clear. Okay, good to go. So now, if you know how to take out the power set of a number, if you know that power set thing, the thing is that if there are three numbers a1, a2 and a3, what are the possible combination of a1, a2 and a3? The possible combination would be the number of set bits from 0 to less than 2 to the power n minus 1. What I am trying to tell you, I am showing you. Okay, suppose we have from 0 to the power n minus 1. From 0 to the power 3 is equals to 8 and 7. From 0 to 7 itself. Okay, we want this. Okay, okay, good to go. So this is good, quite good. So this is from 0 to 7 itself. Okay, from 0 to 7. Okay, now how would we proceed? Just see this. This is 0, so we have an empty set. That would be empty. Okay, and here we have the last bit set, so we would just write a3, and we have the second bit set, we would write a2, and then we have the last two bit, that is a2 comma a3. Okay, and then we have a1, and then a1 here, and then a3 here. This is a1, this is a3, and again I can write a1 and a2. Okay, this is good to go, and I can write a1, a2 and a3. These are all the possible combination of this. So whenever there is a set bit, we take that number. If that is not set bit, we don't take that number. Why I am telling you the power set approach? Because this power set approach is absolutely very important when we talk about the bitwise operation. So this was very important, so I told you this. Okay, moving forward. So now we can see that we can tell the number of possible combination. Okay, so if we just observe this, so if we just observe this, just let me clear this. Yeah, so if we just observe till 2 to the power 3 minus 1, then we can see that this is having all the possible combination. Okay, like The first one is 0, the next one is 1, the first one is, third one is 0, 1, 0, 1, 0, 1. And the next one is that 0, 0, 1, 1, 0, 0, 1, 1. And the next thing is that 0, 0, 0, 0, 1, 1, 1, 1. Okay, so we can see that we follow a definite pattern, like after 1, after 2, after 4, then after 8, after 16. We have 1, after 8 we have a different, we have 0, then again this value, like after 1, 0, 1, 1, 2, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. Okay, this is quite good. So we can see that what we can do is to take out the values, till this point, till this point, 2 to the power 3, that is the highest power of 2 that is available within the number. The highest power of 2, suppose this is 11, so 2 ones are 2, okay, 2 twos are 4, 2 threes are 4 twos are 8, okay, and then 8 twos are 16. 16 is greater than the number, so we would be taking this 8 itself. Okay, good to go. Okay, okay. I don't know if there is a problem with my side or with other side. Let me just check, okay? Let me just check for once. Just a sec. I don't know what is happening here. Okay, yeah, I found my video. Okay. Don't know what is happening. Okay. So I don't think anyone is replying, or I'm not able to figure it out. Okay, so whatever be the reason, I don't know. So we can see that this is till 8, so 8 by 2, okay, 4 digit, and then again 8 by 2, then again 8 by 2. We have these three, so that would be 8 by 2 into 3, 8 by 2 into 3. So this is 2 to the power 3 by 2 into 3. So whenever the base is same, that would be 2 to the power 2 multiplied with 3. 2 to the power 2 is equals to 2 to the power n minus 1 multiplied with 2. And what is 2 to the power n? The 2 to the power n is equals to the highest power minus 1. Okay. So we can see that how many numbers we have? We have total 2 to the power, that is 2 to the power 2 multiplied with 3, that is 4 into 3, that is 12. So we have 4, 4, 4, that is 12 itself. So we can see that highest power of 2 till this point, we can calculate the value as 2 to the power n minus 1 multiplied with n. Okay, good to go. So now we would talk about this part. Okay, we would talk about this part. Now when we are talking about this part, okay, we can see that all the bits are set. These all the bits are set, and if you look at this next part, you can see that again it is 0 1 0 1 0 0 1 1 and again 4 0. So what we can do is we can take this value, that is remaining. Okay, so remaining, we would add the remaining and we would delete it. Now we can see that again we can solve it for, this is 0, this is 1, this is 2, and this is 3. So what we can do is 2 to the power n minus 1 multiplied with n, and then add the remaining, and then again recursively put the solution. Why this is put the solution? Because this is again the same as we have solved it previously. Okay, so again recursively rest part. Okay, am I clear till this point or not? Can I have a quick +1 in the chat that I am clear till this point or not? Can I have a quick +1 in the chat that I am clear till this point? Just let me know if I am clear till this point or not. Okay, I don't know what is the problem today. No one is replying. Okay, so we would move forward with the approach. Okay, so moving forward, we can see that this is the case. Now, how would we solve this? Now, the first problem is that suppose we have a number 12 itself, or we have a number 7 itself. The first thing is that we need to tell the highest power of 2 which is within the range. Okay, this value would be 2 to the power 3, that is 2 into 2 into 2 into 2. Okay, that is 4, 4 to the 8, 8 to the 16. So this was, sorry, I am 4, this would be 4, and this would be 2 to the power 3. Okay, 2 into 2, that is 8, 8 is less than 12 itself. Good to go. So now we would move forward with this approach. How would we try to solve this? So I don't know if you know this or not, but 1 dash 1 right shift a number, suppose 3, would make it 2 to the power 3. Okay, I am telling you how. Which is the binary representation of this? Okay, this is 2 minus 1, that is the case. Okay, sorry, that is, this is the binary representation of which I am telling you. Okay, this is 0, this is 1, this is 2, this is 3, this is 4 itself. So that would be 2 to the power 2 as I have written. So next thing is that 2 to the power 1 root n plus 1. Okay, so what we can do is 1 1 dash dash 0, that is 1, that is 2 to the power 0. Then again 1 dash dash 1 would make it 0, that is 2 to the power 1. 1 0 0 is 2 to the power 2. 1 0 0 0 would make it 2 to the power 3. This is how we would proceed. Okay, this is the case. Now what we can do is we can do n dash dash c, and while this is smaller we would increment c, and if it is within the range we would just keep doing it, and while it gets outside the range we would just return c minus 1. Why c minus 1? As I told, because the number of right shift minus 1. This is right shift by 2. Okay, so this is 2. Okay, this is good to go. This is how we would proceed itself. So now we would move to the implementation. I hope I am clear with the problem explanation. We would move to the implementation now. Okay. Now to take out the maximum value which is within the range, that is c is equals to 0, and while it is within the range we are just incrementing it. At the end we are returning c minus 1. Okay, this is how we are taking out the maximum power of 2 which is less than the number. Okay, and now we are doing it recursively. Whenever we want to solve any problem recursively, we need a base case. What is the base case? If n is equals to 0, return 0. Why? Because it has no set bits. Okay, the next thing is that I am storing the max power of 2, and what I am doing is 1, and as I told, 2 to the power x minus 1. Okay, that is 2 to the power x minus 1, that is n into 2 to the power x minus 1, that is 3n into me. And then we are subtracting it, and the remaining part would be again sent to the recursion. Okay, at the end I am just returning the value. Okay, I would be waiting for your reply if I am clear. So I would be waiting for 1 minute if this is clear or not. If I don't get any reply within 1 minute, I would be just turning off the session. Okay, I would wait for 2 minutes actually. Okay. One friend of mine told me that there is an issue in the chat. that I am not receiving any chat. Okay, I don't know what is happening here. I don't know the case. If I knew it earlier, I would have resolved with the YouTube team. But now nothing can be done because everyone is texting, but none of the chat are visible to me. I thought there is a glitch from my side. I checked it from the computer also. That is the thing. First, I was checking through my mobile. I thought that my mobile, it might be the case. So I checked it with my laptop also, and it's told the same. I don't know what is the issue, and I don't know how to resolve it. I would ask the YouTube team that it does not persist on the next stream. But for now, the stream has already been complete. I don't know what is the case. Okay, I am just received only one, that is hello sir. Okay, so I don't know what is the issue. I'm not receiving any chat. I checked it from both the ends. Okay, so I think that you all are also not receiving any chat. Just let me know in the comments if this was happening with you. I would be resolving it with the YouTube team. Okay, so that's all for today. I am not getting any doubts because I don't know what is the doubt. But what I would be doing is I would be again explaining you in short. Okay, so now the thing is that we know that we would do from the top to the 2 to the power n minus 1, and this would tell us that what is this? This is 8 by 2, this is 8 by 2, and this would be again 8 by 2. This is 4 plus 4 plus 4. We need a relation, that is 8 by 2. 8 is equals to the power 3, that is 2 to the power n minus 1 into n itself. This is how we can proceed. And then the rest of the things, we would add rest of the things, add rest, and then we are sending again the rest remaining to the again recursion, and that would keep happening till we hit the base case. This is what we are doing. We are just adding the things, and then we are adding the remaining part plus 1, and then the remaining part is again sent back to the recursion. Okay, so that's all for today. Thank you and have a nice day. Be safe, and if possible, please do like and comment the video. Okay, thanks a lot.